The goal of today's lesson is to solve compound inequalities that are joined by the words either and or. So let's start out with a pretty straightforward exercise. We're going to look at 6 compound statements, and we're going to determine if each statement is true or false. Right now, I am in either math or science class. Assuming for a moment you're in period 1 or period 3, this is a true statement. Right now, I am in math and science class. A false statement. 3 plus 5 equals 8. That's a true statement. 5 is greater than 7 minus 1. That's a false statement, but since it's or, it's true. If I continue down the process, statement number 4 is false, while the other 2 are both true. So, what is the observation made? Well, just simply looking at the statements above, as I scroll down to be able to write some, the observation is that the sentences joined by or were all true, while those joined by and were all false. Now, let's make some sense of this. The first thing is a compound statement is 2 distinct statements joined by and or. Now, if you look at what we've done above, we can make the following conclusion or conclusions. For and statements to be true, both, and that's not an E, just a curly H, both statements must be true. For or statements to be true, only one statement needs to be true. Okay. Now, what we're going to do is take this logic concept and apply it to compound inequalities. So, let's look at the first exercise. I want to graph the following 2 inequalities on the number line. Well, x is less than 3 graphs with an open circle going to the left. And x greater than negative 1 is an open circle going to the right. For x to be true in both statements, what has to be true about x? Well, what has to be true is that x has to be between 1, negative 1, and 3. It cannot be negative 1 and 3 since there are open circles there. Well, I can write that as one compound inequality. The desired way is as such. The other acceptable way is x is greater than negative 3 and negative 1, and x is less than 3. Either of these 2 methods, this one or this one, are acceptable. The first one, the one on the left, is more commonly seen. It's a little bit more of a shorthand. So now, how do I put the 2 of them together? I put the open circle on negative 1, the open circle on 3, and that is the only area in which x satisfies both inequalities. So, for example, 0 satisfies because it's in the shaded area. If you substitute 0 in for x, it's a true statement all the way across. Now, let's go to the second example, where I'm going to graph x is less than negative 4, and x is greater than 0. But what's different there from above is no overlap. Can x satisfy the statement x is less than negative 4 and x is greater than 0? No. There is no value of x that satisfies both. But can it satisfy an or statement? Yes. Now, rewriting it, unfortunately, there's no shortcut. I have to write x is less than negative 4 or x is greater than 0. And if I chose any number in either this area or this area, it will make one of the two statements true. So now let's extrapolate this to practice problems. Okay? I want to solve the compound inequality, and the way I would read this is 2x plus 7 is greater than negative 1 and less than 3. The nice thing about it is you're going to solve this using the rules of inequalities. It's just you're doing two of them at once. I like to separate it out like this. I would subtract 7 from each. Divide each by 2. And so I read this as x is greater than negative 4 and less than negative 2. I go to my number line, and there is my graph. What is a value in the solution set? And check it. Well, there technically in math are an infinite number of solutions because there's an infinite number of numbers between two numbers on a number line. But we want to stick with integers if we can. And we see that negative 3 is a solution. How do I check that? Substitute in negative 3 for x and solve. And you will see this is a true statement. And so you have graphed this properly. Now I want to, on the other hand, do it with an or statement. So x plus 4 is less than 2, or x is greater than or equal to 3. So I solve both in terms of x. One of them is already done for me. And I see x is less than negative 2, greater than or equal to 3. Now, I want to identify a value not in the solution set. Well, let's take an easy one, 0. I put 0 in for x, and I get this untrue statement, and I put 0 in for x again. Both statements are not true, thereby showing that I have graphed this correctly, or I should have graphed this correctly. For an or statement to be false, it makes both parts false. All right, so let's run through the next examples. I have the compound inequality separated by and. Just solve them separately. I get x is less than 2. And x is greater than 0. I'm going to graph that on the number line. Open circles, and there's my solution set. Okay. Next one is or. Again, you're just solving two separate inequalities. If you don't remember, look back at your inequality video. X is less than or equal to negative 3, or hopefully you are remembering that when you divide or multiply by a negative, you have to flip the inequality symbol. So here I get x is less than or equal to negative 3. X is greater than 1. Next one, and these become kind of redundant after a while. So I want to solve each of these. So x is greater than or equal to negative 4, and x is less than 2. And again, what you should be getting in the habit of looking for is if it's an and, you are looking for an overlap. And if it's an or, you're looking for no overlap. That's not always the case, but most of the time that is true. And then the final example, scroll down. 7 is greater than 3x minus 2. Add 2. 9 is greater than 3x. And again, you want to read this as x is less than 3 or x equals 4. X being less than 3, I put an open circle over the 3. X equaling 4, I just put a circle over the 4. Okay? So to summarize, when solving compound inequalities, they are going to be separated by and or. If they're separated by and, I need to satisfy both distinct statements. If they're separated by or, I only need to satisfy one of the two. When graphing, in and, you should most of the time see an overlap. In or, you should see no overlap. That's not always the case, but that is true most of the time.